Methodology, study notes for PhD entrance exam. Unit 1, Research and types of research. 1.1 Meaning of research. Research is a systematic, organized, and objective investigation carried out to discover, interpret, or revise facts, theories, or applications. It is a scientific and systematic search for pertinent information on a specific topic. Research involves defining a problem, formulating a hypothesis, collecting and analyzing data, and reaching conclusions, either to test the hypothesis or to arrive at generalizations that add to existing knowledge. Key characteristics of research: systematic and controlled, empirical based on observable evidence, objective and logical, replicable and verifiable, aims at generalization or theory building. 1.2 Objectives of research. Exploratory, formulative research, to gain familiarity with a phenomenon or achieve new insights. Descriptive research, to accurately portray characteristics of an individual, group, or situation. Diagnostic research, to determine the frequency of association between variables. Hypothesis testing research, to test a causal relationship between variables. Broadly, research aims to discover new facts, verify old facts, analyze events, processes to establish cause-effect relationships, develop new tools, concepts, or theories, find solutions to practical, scientific problems, contribute to existing knowledge base. 1.3 Motivation in research. Common motivating factors behind undertaking research. Desire to get a research degree with its benefits. Desire to solve unsolved problems. Desire to face intellectual challenge. Desire to be of service to society. Desire to get respectability. Directives from government, employer bodies. Curiosity about new things. Desire to understand causal relationships. Requirements of the job: contract research, consultancy. 1.4 Research methods versus research methodology.
Difference.
Aspect research methods. Research methodology meaning techniques, tools used to conduct research, e.g., data collection, statistical tools. The science, philosophy of studying how research is done systematically. Scope narrower, concerned with the how of specific tasks. Broader, includes methods plus the logic behind choosing them. Focus execution of the study. Design, rationale, and validity of the research process includes techniques for collecting data, sampling methods, statistical techniques. Study design, assumptions, criteria used to evaluate methods, and their applicability. In short, methods equals the tools, methodology equals the study of which tools to use, why, and how, in a given context. 1.5 Types of research. 8 Descriptive versus analytical. Descriptive research includes surveys and fact-finding inquiries, describes the state of affairs as it exists, e.g., status studies. Researcher has no control over variables, can only report. Analytical research uses existing facts, information to make a critical evaluation of material, often to establish new facts or interpretations. B. Applied versus fundamental. Basic. Applied action research aims to find a solution for an immediate, practical problem faced by society, organization. Fundamental, pure, basic research, concerned with generalizations and formulation of theory, gathering knowledge for its own sake, e.g., pure mathematics, natural phenomena studies. C. Quantitative versus qualitative. Quantitative research, based on measurement of quantity, amount, data expressed in numbers, analyzed statistically. Qualitative research, concerned with qualitative phenomena, attitudes, motivations, opinions, behavior, often uses interviews, focus groups, case studies. D. Conceptual versus empirical. Conceptual research, related to abstract ideas, theories, used by philosophers, thinkers to develop new concepts or reinterpret existing ones. Empirical research, data-based research relying on experience, observation alone, often with or without regard to theory, conclusions verifiable by observation or experiment. Other classifications: supplementary, one-time versus longitudinal research, field setting versus laboratory, simulation research, historical research, clinical, diagnostic research, exploratory research, research process. The research process consists of a series of closely related, often overlapping, steps. Formulating the research problem, identifying and defining the problem clearly. Extensive literature review, surveying existing knowledge. Developing hypotheses, formulating tentative propositions. Preparing the research design, deciding on the blueprint, exploratory, descriptive, experimental. Determining sample design, deciding sampling technique and sample size. Collecting data, through observation, interviews, questionnaires, experiments. Execution of the project, actual fieldwork, data gathering under supervision. Analysis of data, applying statistical qualitative techniques. Hypothesis testing, accepting or rejecting hypotheses based on analysis. Generalizations and interpretation, drawing broader inferences. Preparation of the report thesis, writing up findings in a structured format. Note: this is a logical sequence, not strictly linear, steps often overlap and involve backtracking. 1.6 Criteria of good research. A good research study should satisfy the following criteria. Purpose clearly defined, objectives stated in common, unambiguous terms. Research process detailed, procedures described in sufficient detail for replication. Research design well planned, yields results as objective as possible. High ethical standards applied, honesty and transparency maintained. Limitations frankly revealed, researcher reports flaws, limitations honestly. Adequate analysis for decision making, sufficient data analysis to reveal significance. Findings presented unambiguously, conclusions justified by data and methods used. Conclusions confined to justified data, researcher doesn't overgeneralize. Greater confidence in research, if researcher is experienced, has good reputation, and follows ethical norms. Unit 2. Research formulation, defining and formulating the research problem. 2.1 Selecting the problem. Guidelines for selecting a research problem. Avoid overdone, oversaturated topics unless a new approach is possible. Avoid controversial topics for beginners unless well suited. Too narrow or too vague problems should be avoided. The subject should be familiar and feasible in terms of time, cost, and resources. Importance, urgency, suitability of the researcher, availability of data, and cost involved should guide selection. 2.2 Necessity of defining the problem. A clearly defined problem is the foundation of good research. Provides direction to the research and prevents wastage of resources. Helps determine the data to be collected and the techniques to be used. Guards against faulty conclusions. Enables the researcher to plan the study logically. A problem clearly stated is a problem half solved. A poorly defined problem leads to confusion at every subsequent stage. Steps in defining a research problem. Statement of the problem in general terms. Understanding the nature of the problem. Surveying available literature. Developing ideas through discussion with colleagues, experts. Rephrasing the problem into a working, operational form. 2.3 Importance of literature review in defining a problem. A literature review helps the researcher understand what has already been done, avoiding duplication. Identify gaps, contradictions, or unresolved issues in current knowledge. Refine and sharpen the research problem objectives. Identify appropriate theoretical frameworks and methodologies used by others. Understand terminology, variables, and measurement tools used in the field. Build a strong rationale, justification for the proposed study. 2.4 Literature review, sources. Primary sources, original, first-hand accounts of research. Original research articles, papers published in journals. Theses and dissertations. Conference proceedings. Patents. Technical research reports. Raw data, lab notebooks, letters, original documents. Secondary sources. Interpretations, summaries of primary sources. Textbooks. Reviews, critical summaries, evaluations of research on a topic published in reviewed journals. Treatises, comprehensive, systematic written accounts of a subject. Monographs, detailed, scholarly studies focused on a single specialized topic. Encyclopedias, handbooks. Newspaper, magazine articles. Patents, a significant but often underused source, particularly in technical, scientific research, revealing state-of-the-art technology. Novel methods, processes, products not yet published elsewhere. Prior art for assessing novelty of a proposed innovation. Web as a source, search engines, digital libraries e.g., Google Scholar, IEEE Explore, Science Direct, PubMed institutional repositories, preprint servers e.g., archive and government organizational databases. Searching the web effectively. Use specific keywords and Boolean operators and, or, not. Use quotation marks for exact phrases. Use advanced search filters date range, publication type, subject. Use citation databases Scopus, Web of Science to trace citation trails. Evaluate source credibility peer-reviewed versus non-peer-reviewed, authority of publisher. 2.5 Critical literature review. A critical review goes beyond summarizing, it involves comparing and contrasting different studies' methodologies and findings. Evaluating the strengths, weaknesses, and limitations of existing studies. Identifying inconsistencies, contradictions, or unanswered questions. Synthesizing findings across multiple sources into a coherent narrative. Situating the proposed research within the existing body of knowledge. 2.6 Identifying gap areas from literature review. Gaps commonly identified include knowledge gaps, areas not yet studied. Methodological gaps, limitations in methods used by prior studies. Contradictory findings, conflicting results needing resolution. Population context gaps, studies not covering certain populations, geographies, or time periods. Practical application gaps, theoretical work not yet tested in practice. Identifying these gaps provides the justification and novelty for the proposed research. 2.7 Development of working hypothesis. A working hypothesis is a tentative, testable assumption proposition formulated to guide the research and provide a focal point for investigation. Sources for formulating hypotheses. Discussions with colleagues and experts. Examination of available literature data. Analogy, similar problems solved elsewhere. Personal experience and observation. Exploratory pilot studies. Characteristics of a good hypothesis. Clear, precise, and testable. Stated in simple, understandable terms. Consistent with known facts. Limited in scope, specific, not too general. Capable of being tested within a reasonable time frame. Unit 3, Data Collection and Analysis. 3.1 Execution of the research. Execution refers to the actual implementation of the research design in the field. Setting up the necessary organizational, administrative arrangements. Ensuring the research proceeds strictly on schedule. Maintaining periodic checks to ensure data quality and honesty in data collection. Handling non-response and unforeseen field problems. 3.2 Observation and collection of data. Data can be primary collected firsthand or secondary already collected by someone else. 3.3 Methods of data collection. A. Observation method, systematic viewing, recording of behavior, events as they occur, structured or unstructured, participant or non-participant. B. Interview method, direct verbal interaction, structured, unstructured, or focused depth interviews. C. Questionnaire method, set of written questions sent, administered to respondents. D. Schedule method, similar to a questionnaire, but filled by the enumerator investigator on behalf of the respondent. E. Other methods, case study method, projective techniques, warranty cards, panels, focus group discussions, and secondary data sources published reports, government publications, prior research. 3.4 Modeling and mathematical models for research. Modeling involves creating a simplified representation of a real system phenomenon to study its behavior. Types of models used in research. Descriptive models, describe relationships, structures. Predictive models, forecast future outcomes, e.g., regression models. Normative optimization models, prescribe the best course of action, e.g., linear programming. Simulation models, replicate system behavior over time, e.g., Monte Carlo simulation. Mathematical, statistical models, expressed through equations, e.g., regression equations, differential equations, probability models, queuing models, Markov models. Models help researchers simplify complexity, test hypotheses computationally, and predict outcomes under varying conditions before without real-world experimentation. 3.5 Sampling methods. Since studying an entire population is often impractical, researchers select a sample. Probability sampling, random selection, every unit has known chance of selection. simple random sampling, systematic sampling, stratified sampling, cluster sampling, multi-stage sampling, non-probability sampling, selection not based on randomization, convenience sampling, judgmental purposive sampling, quota sampling, snowball sampling. Key considerations: sample size determination, sampling error, representativeness of the sample. 3.6 Data processing and analysis strategies. Data processing steps: editing, checking data for completeness, consistency, accuracy. Coding, assigning numerical, symbolic values to responses for analysis. Classification, arranging data into groups, classes based on common characteristics. Tabulation, summarizing data in table form. Analysis strategies. Descriptive analysis, measures of central tendency, mean, median, mode, dispersion, range, variance, standard deviation, and distribution shape, skewness, kurtosis. Inferential correlational analysis, correlation, regression, analysis of variance, ANOVA. Multivariate analysis, factor analysis, cluster analysis, discriminant analysis, multiple regression. Qualitative analysis, thematic analysis, content analysis, coding of narrative textual data. 3.7 Data analysis with statistical packages. Common statistical software used. SPSS statistical package for the social sciences. R open source statistical computing. Python with libraries such as Pandas, NumPy, SciPy, StatsModels. MS Excel basic statistical functions, data analysis toolpack. MATLAB, Stata, Minitab specialized statistical engineering computation. These tools help perform descriptive statistics, hypothesis tests, t-test, chi-square, ANOVA, regression and correlation analysis, visualization, histograms, scatter plots, box plots. 3.8 Hypothesis testing. Hypothesis testing is a statistical procedure to decide whether to accept or reject a null hypothesis H in favor of an alternative hypothesis H. Steps in hypothesis testing. State the null and alternative hypotheses. Select the appropriate test statistic, z-test, t-test, chi-square, f-test, etc. Set the level of significance alpha, commonly 0.05 or 0.01. Determine the critical region, critical value. Compute the test statistic from sample data. Compare and decide, accept or reject H. Interpret the result in context. Errors in hypothesis testing. Type 1 error, rejecting a true null hypothesis, false positive. Type 2 error, accepting a false null hypothesis, false negative. 3.9 Generalization and interpretation. Generalization, extending conclusions drawn from a sample to the wider population, provided the sample is representative and the study design is valid. Interpretation, explaining the meaning and implications of the findings, linking results back to the research objectives, hypotheses, situating them within existing theory, literature, and discussing practical or theoretical significance. Good interpretation also involves acknowledging limitations and possible alternative explanations. Avoiding overgeneralization beyond the scope of the data. Suggesting areas for further research. Preparing the final report thesis with clear conclusions and recommendations. Quick revision summary. Topic: Key idea: research, systematic investigation to discover, verify knowledge, methods vs methodology, tools versus the science of choosing, justifying tools, research types, descriptive, analytical, applied, fundamental, quantitative, qualitative, conceptual, empirical, research process, problem, right pointing arrow, literature, right pointing arrow, hypothesis, right pointing arrow, design, right pointing arrow, sampling, right pointing arrow, data collection, right pointing arrow, analysis, right pointing arrow, testing, right pointing arrow, interpretation, right pointing arrow, report. Good research objective, well planned, ethical, transparent about limitations, problem formulation, clear definition plus literature review plus gap identification plus hypothesis, literature sources, primary, journals, theses, patents versus secondary, reviews, treatises, monographs, textbooks, data collection, observation, interview, questionnaire, schedule, Case study sampling probability random, stratified, clustered versus non-probability convenience, purposive, quota, snowball, analysis descriptive stats, inferential tests, multivariate methods, software SPSS Python, hypothesis testing state right pointing arrow choose test right pointing arrow set alpha right pointing arrow compute statistic right pointing arrow decide right pointing arrow interpret.